Hello, welcome back. And the math puzzle of today is this question here. Is about pizza, one of my favorite topics. I really think pizza is one of my favorite things in the world. What is the best option? If you go to your favorite pizza place and you have these two options here. One is a large pizza, 18 inches at $9 each. And another one, two medium pizzas, 12 inches, for $75 each. Which one is the best value for money? What do you think is the best option? Number one or number two? Think about this puzzle. At the end of the lesson, we will show you the answer, how to solve it. And today we are working on chapter 2, Equations, Inequalities and Problem Solving. Section 2.4, Linear Inequalities and Problem Solving. And we will work with inequalities, and which is, inequality is a statement that contains one of the symbols, less than, greater than, less than or equal to, greater than or equal to. On this left hand side here we have examples of equations. X equals 3, 12 equals 7 minus 3y. Those are examples of equations. On the right hand side, inequalities. X greater than 3, 12 less than or equal to 7 minus 3y. So those are inequalities. Objective number 1, use interval notation. A solution of an inequality is a value of the variable that makes the inequality a true statement. The solution set is the set of all solutions. And we can represent the solution set using set notation, using graph, and most commonly using interval notation. So let's check each one. Set notation, if we have x less than a, that means x is all the numbers that are in this interval here, starting from a, the number a, going all the way to negative infinity. So here is going to be negative infinity, okay? So all this is the interval where you can find solutions for this inequality. And I'm going to represent using interval notation by using parentheses, negative infinity, comma, a, parentheses. The parentheses have the meaning that the endpoints, let's say a and negative infinity, they are not included on the interval. And one thing that you have to remember, every time you use infinity, you will use parentheses, because infinity is not a number. Infinity is a representation or something that you never can reach. It's really far, far away. It's a huge or a small number that you cannot reach. The second example here, x greater than a. So everything that is greater but not equal to a. Greater but not equal, and go all the way to positive infinity. We will represent as parenthesis a, comma, infinity. Another parenthesis here. The next one, x is less than or equal to a. When we have this equal sign here underneath the inequality symbol, we will use the bracket to symbolize, to represent that this endpoint is included on the interval. It belongs to the interval. And then this goes from negative infinity to a, and a is included. So represent using interval notation, parenthesis, negative infinity, comma, a, bracket. That means a is included. Another one, x is greater or equal than a. So if we have the equal sign here underneath, that means we're going to use the bracket. A is included, and everything that's greater than A is also included in the interval all the way to positive infinity, and we will represent as bracket A, comma, infinity. Don't need to represent positive, just infinity. Okay? And we also have intervals that are limited. They are limited between two different points. And the first example here, A is less than X, which is also less than B. We represent using the graphing representation is like this, right? Parentheses, because the endpoints are not included, but everything between the endpoints are included. And interval notation is A, comma, B, parentheses. Next one, now we have the equal sign underneath the inequality. See? A is less than or equal to X, which is also less than or equal to B. And now we're going to use the brackets, and everything in between is included. The representation in interval notation is bracket A, comma, B. And we have this other situation where one of the endpoints is not included, another one is included. A is less than X, which is less than or equal to B. This is the graphing. And the interval notation is parentheses A, comma, B, bracket. Another situation, A is less than or equal to X, which is also less than B. That means A is included, B is not included, so bracket, everything here in between is included, but B is not included. A, B, parentheses. And one final situation here is when the solution is all real numbers, the set of all real numbers. And this goes from negative infinity all the way to positive infinity, and we will represent like this, negative infinity, comma, infinity. Always use parentheses when representing infinity or negative infinity. A few examples. Graph each set on a number line and then write interval notation. So the first one, letter A. X is greater than or equal to 2. So find number 2 here. Number 2, right here. Number 2 is included. That means we will use brackets. So bracket here. And everything that's greater than or equal to number 2 is included in this interval. So this, all the way to infinity. The interval notation of this is brackets 2, comma, infinity, parentheses. Letter B. X less than negative 1. Find negative 1, right here, negative 1. Is less than, that means we don't have the equal sign underneath the inequality. Represent with the parentheses, and everything that's less is included all the way to negative infinity. And the interval notation is going to be parentheses, negative infinity, comma, negative 1. And parentheses, because negative 1 also is not included. Now, example C is an interval between 0.5 and 3. 0.5 is less than X, which is less than or equal to 3. So let's find the interval. 0.5 is here, right? 0.5 between 0 and 1, and 3 is right here. 0.5 is not included. See, you don't have the equal sign underneath the inequality. But 3, yes, 3 is included. So we're going to represent with a bracket because we have the equal sign. Everything in between is included. We will represent using interval notation as parentheses 0.5, comma 3. Oops, sorry. And 3 is included. 3 we will represent, we will use the bracket. Moving on to next objective, number 2, solve linear inequalities using addition property. You might remember the addition property from equality, and we also have addition property of inequality. It's very similar. If we have A, B, and C, which are real numbers, if A is less than B, then we can write A plus C is less than B plus C. This is going to be true as well. This is the addition property of inequality. We will be using it to solve inequalities. Example, solve this inequality here. X minus 2 is less than 5. Applying addition property, right? You have x minus 2. This is less than 5. If we want to apply addition property, we can add on both sides 2, and the inequality stays, is still valid. We can simplify, and we have x less than 7. This is the resulting inequality, which we can represent using the number line. Find 7 right here, and everything that's less than 7 is included. Let me just have more. Yeah, everything that's less than 7 is included here. Okay, all the way to negative infinity. If you want to represent using the interval notation, is going to be negative infinity 7 and parentheses. If you want to represent using set notation, is x such that x is less than 7. Next example, solve, and there's this inequality here, 3x plus 4 greater or equal than 2x minus 6. We can apply addition property to solve this. We can add. Remember, when we're working with addition property of equality, the objective is to move every variable to one side of the equation and every number to the other side of the equation. Keep only variables in one side and only numbers on the other side. Here is going to be the same. We will remove the variables from one side, we will remove the numbers from the other side, and reorganize this. Let's, what we're going to do, let's subtract 4 on both sides, so we can get rid of this 4 here on this side. And another thing that we can do is subtract 2x from both sides. Then we simplify here, we have only x on the left hand side, so 3x minus 2x, x greater than or equal to negative 6 minus 4, negative 10. See? If you want to write this as set notation, add here x such that x is greater or equal than -10. This is set notation. Representing using the number line, we have the equal sign. That means we will represent using the bracket here on 10, and everything that's greater than -10, I mean everything that's greater than -10 and greater is on the right hand side of the number line, is included all the way to infinity. This is set notation. An interval notation is not this, not parenthesis, bracket, -10, because -10 is included, all the way to infinity. Every time you represent using infinity, you're gonna use parentheses. Interval notation is this. Next example. Now we're moving to the next objective. Solving a linear inequality using the multiplication and addition properties. As we have the multiplication property of equality, the same thing we're gonna have the multiplication property of inequality. And it goes like this. If you have A, B, and C as real numbers, suppose if A is less than B, you can make A times C less than B times C, as long C is a positive. Okay, C needs to be a positive number. You can say this is true as long as C is positive. But if C is a negative, what is going to happen? If C is a negative, if you have A less than B, you can have a conclusion here. A times C compared with B times C is going to be greater than. If you have C negative, you have to flip, to switch the inequality sign. And example, let's work on this example here. 1 over 4x is less or equal than 3 over 2. Well, we can first we can apply here multiplication property of equality to get rid of the fractions. And my suggestion is to multiply. Let's work first here. Let's repeat. 1 over 4x less or equal than 3 over 2. And my suggestion is to get rid of this 1 over 4 here in front of x by multiplying both sides by 4. You are multiplying by a positive number. That means you can say if they stay less than or equal to, you don't need to flip, right, to keep the same inequality sign. This is simplified. X is going to be less or equal than 3 times 4. 12 divided by 2, 6. And find here 6. You have less than or equal to, means bracket. Everything that's less or equal than 6 is included on the interval all the way to negative infinity. And if you want to represent this using interval notation, it's going to be from negative infinity with a parenthesis, comma, 6 bracket. This is using interval notation. And just remember, if you want to represent using set notation, is x such that x less than or equal to 6. This is set notation. Set notation, interval notation. Okay, moving. more examples, and we have another interesting example here. Negative 2.3 x less than 6.9. Check this. Let me write again. Negative 2.3 x less than 6.9. We can multiply. We want to have only x and eliminate or get rid of this negative 2.3, right? So we can multiply both sides. Let's multiply both sides by negative 1 over 2.3. If we do this, we eliminate, we get rid of this negative 2.3 in front of x. But when we do this, and we have to do in both sides, we have to multiply both sides, but then we are multiplying by a negative number, both sides. Remember what the property says? That when we multiply both sides by a negative number, the multiplication property of inequality says you have to flip the inequality sign. So now we have the sign pointing to the other side, right? So simplify, this becomes positive, negative with negative, positive, and then we will have on the left hand side x greater than, and 6.9 divided by negative 2.3 is negative 3, right? Negative 3. And wait, if we want to write this down using set notation, is x such that x is greater than 3, the negative 3. If we want to represent on the number line, find negative 3, this is greater, right? Greater than negative 3. Negative 3 is here. Everything greater than negative 3 is solution of this inequality all the way to infinity. And if we want to represent using interval notation, it's going to be from negative 3 to infinity with parentheses on both sides. So this is set notation. This is, oops. This is interval notation. Okay. Remember, the inequality symbol is going to be reversed when we divide by a negative number or multiply both sides of an inequality by a negative number. Okay, remember this is always going to happen. Objective number 4, solve linear inequalities using both properties of inequality. We will apply addition property and multiplication property, and the step-by-step is this. Step 1, clear the equation of fractions by multiplying both sides by the lowest common denominator. Step 2, use distributive property to remove grouping symbols. Step 3, combine like terms on each side of the inequality. Step 4, use the addition property of inequality to rewrite the inequality as an equivalent inequality with variable terms on one side and numbers on the other side. So split, make sure you have variables in one side and numbers on the other side. And 5, use the multiplication property of inequality to get a variable alone. Example, and let's do this step by step, really carefully. First thing, you have 3x plus 9 greater than or equal to 5 times parentheses x minus 1. First, apply the distributive property. Distributive property is something like that. And multiply 5 times x minus 5 times 1. So we have 3x plus 9 greater than or equal to 5 times x, 5x, 5 times negative 1, negative 5. Now you can apply additional property, subtracting 3x from both sides. Let's do right here. Subtract 3x, or add negative 3x is the same thinking, right? And we will have 9 greater or equal than 2x minus 5. Simplify, okay, add 5 to both sides. Let's do it right now. Add 5 on both sides. And then we simplify here, and we will have 9 plus 5, 14, greater than 2x. And that's it. The last step is applying multiplication property of equality and dividing both sides by 2, or we can think multiplying both sides by 1 over 2 is the same thing. We will have, as a result, let me write it here, 14 divided by 2 is 7. Is greater than or equal to x. Look, we have this, and we can represent now using the number line, right? So 7 is greater than or equals to 7. We can write like this. Or we can switch sides. When you switch sides, the same thing. You have to flip the inequality sign. So x is going to be less than or equal to 7. Okay, it's the same thing. Just switch sides, and we have to flip the inequality. To represent using set notation, x such that x is less than or equal than 7. This is set notation. Writing down here on the number line, use the bracket on 7 because 7 is included. We have an equal sign, right? And everything that's less than 7 is also included all the way to negative infinity. That means interval notation is from negative infinity to 7 brackets. Okay? Set interval notation. And one more example. Now I have a long inequality here to solve. 7 times x minus 2 plus x is greater than negative 4 times x minus 5 minus x, parentheses, minus 12. And the first thing we will do is distributive property on both sides. So distributive property here, distributive property here. Rewriting is 7x minus 7 times negative 2 is negative 14 plus x greater than negative 4 times 5, negative 20, and negative 4 times negative x, positive 4x minus 12. Combine like terms. The next thing we will do, we can combine this, 7x with x, and we can combine that. Look, negative 20 with negative 12. So we will have 7x plus x, 8x minus 14, greater than, and let me just write down here, 4x minus negative 20 minus 12, negative 32. right? We will apply addition property of equality, and let's add negative 4x on both sides, negative 4x, and let's add, because we will simplify here, let's add 14 on both sides, because we will simplify this one here. Then 8x minus 4x, 4x, 0, greater than 0, negative 32, plus 14 is going to be 18, right, negative 18. Finally, apply multiplication property of equality. Multiply both sides by 1 over 4. And is a positive number. We don't need to be worried about the inequality. We keep the inequality. So x is greater than negative 18 divided by 4 is negative 9 over 2. Okay, this is if you want to represent using sets notation, x such that x is greater than negative 9 over 2. If you want to represent using interval notation, first let's check here on the number line. 9 over 2 is negative 4.5, right? Negative 4.5. Negative 4.5 is here. And it's not equal. So parentheses. And everything greater than negative 4.5 is included all the way to infinity. Using interval notation, negative 9 over 2, infinity. This is the representation. And now we move to the next objective. Number 4, solving problems modeled by linear inequalities. So you're having a catered event, you can spend at most $1,200. This is your budget. You cannot spend more than that. The setup fee is $250 plus $15 per person. So find the greatest number of people that can be invited and still stay within the budget. Let's say X is the number of people. That means you will pay for this event $250 is a one-time fee, just pay and that's it, plus $15 per person, 15 times X, right? And this amount here needs to be, cannot exceed $1,200, is less than or equal to 1,200. Now you can solve applying addition property, multiplication property of inequality, and solve this inequality to find X. Let's say subtract 250 from both sides, right? Or add negative 250, applying addition property of inequality, and this is going to be 15x less than or equal to 950. Is 1200 minus 250. Now multiply both sides by 1 over 15. So you can multiply both sides by 1 over 15. And then you have x is less than or equal to 950 divided by 15 is 63.3. This is the maximum amount of people that you can invite, but you might agree with me that you cannot invite 0.3 people, right? Not 1/3 of a person. That's not doesn't make sense. So the maximum, the number of people who can be invited must be 63 people or less to stay within the budget. This is our conclusion. This ends section 2.4. This is the last example. And now let's check out our puzzle. What do you think? Option number 1 or option number 2? Well, to solve this puzzle, you need to remember the formula for the area of the circle. And the area of the circle is pi times r squared, right? For the first one, for option number 1, you will have pi 3.14, let's say, approximately, times, and the radius is half the diameter, 9 squared, is approximately 255, approximately 255 inches squared. Okay. Now the option number 2, two areas. We have two pizzas, so 2 times the area of one, 2 times pi times, and the radius is going to be 12 divided by 2, 6 squared. And if you calculate it, you're going to find approximately 226 inches squared. That means option number 1 have more area, more pizza, and the price is a bit less than option number 2. The answer is, the best option will be option number 1. Thank you for watching this video, and see you next time on the following section.